Hello everyone, once again welcome to MPLS series. Guys, in this video of MPLS series, we are going to understand IPv6 over MPLS 6PE. 6PE is IPv6 PE. PE stands for provider edge. So we can say 6PE or IPv6 PE, or we can say IPv6 provider edge. So what is 6PE or 6 IPv6 PE? So understand 6PE or 6 provider edge is a technology used in MPLS network to enable the transport of IPv6 traffic over an IPv4 MPLS core network. Like you can see in here in MPLS, in service provider network, we have IPv4. This is IPv4 network, right? Here we are running MPLS over IPv4. Okay, and we want to provide IPv6 connectivity to customer. So as you know, MPLS packets are forwarded based on label rather than traditional IP routing, which makes it possible to transport different type of traffic like IPv6 over MPLS network, right? Because in service provider network we are MPLS forward traffic on the basis of label, so we can forward IPv6 traffic also on IPv4 network. And 6PE allows service provider to offer IPv6 connectivity to their customer while using existing IPv4 MPLS infrastructure, right? Service provider don't need to upgrade their network from IPv4 to IPv6. Here we are running MPLS. Because of that, we can provide IPv6 connectivity to customer. Okay, so this is another method. 6P is another method to provide IPv6 connectivity to customer and using IPv4 MPLS network in service provider. Okay, so you will understand the configuration, but first it is important to understand what is 6PE. So 6PE allows service provider to offer IPv6 connectivity to their customer while using a existing MPLS infrastructure without upgrading their infrastructure to IPv6. Now configuration, how we will configure it. Okay, because this is clear to you that what is IPv6 over MPLS. IPv6 over MPLS means providing IPv6 services over MPLS. Okay, so let me show you the configuration. Here in the notepad I have configuration of all router. Guys, here what I will do, directly I am going to configure BGP neighborship between router 1 to router 3. See this topology. In this topology we have again two customer A and customer B. This is side 1 of customer A, this is side 2 of customer A, this is side 1 of customer B, and this is side 2 of customer B. So here we don't need to exchange IPv6 prefix between router 1 and router 2. Here I don't need to exchange IPv6 prefix between router 1 and router 2. So we will not configure BGP neighbor between router 1 and router 2 today. Also we will not configure BGP neighbor between router 1 and router 4, because router 1 is connected with different customer and router 4 is connected with different customer. Router 5 is also not my route reflector today in this video. So let me delete it. Here this is not route reflector. Router 5 is not route reflector in this scenario, because see I need to exchange IPv6 prefix between router 1 and router 3. So we will configure one BGP session between router 1 and router 3, and we will configure one BGP session between router 2 and router 4 only, right? We will not configure route reflector or BGP neighborship between router 1 to router 5 or router 5 to router number 3. Directly we will form BGP neighborship between router 1 and router 3, and directly we will form one more BGP neighborship between router 2 and router 4. Okay, and then we will exchange prefix of side 1 of customer A to side 2 of customer A, and side 1 and side 2 of customer B. Okay, so requirement is what? Requirement is 1.1.1 should reachable with 3.3.3 and 2.2.2 should reachable with 4.4.4. so here also we don't need to create loopback today. So if loopback is there on router number 5, we can ignore it, or we can remove that loopback also, because in 6PE we will not configure loopback on router number 5, because we are not going to configure BGP neighborship to any router with router number 5. Okay, in 6PE we will directly configure BGP neighborship between PE to PE. Like this is router 6 is 6PE router, and router 3 is other 6PE router. So we will configure BGP neighborship between 6PE to 6PE. This is also 6PE router, and this is also 6PE router. So we will configure BGP neighborship between router 2 and router 4, between router 1 and router 3 only. So you can see on router number 1 configuration is very easy. Okay, so that's why I have mentioned, I have uh, I have write down all command in notepad. Okay, on router number 1 you can see, first of all, I am enabling IPv6 unicast routing on router number 1. After that, router BGP 65000 and no BGP default IPv4 unicasting, because it is not required. And then directly neighbor 3.3.3 remote AS 65000. Neighbor on router number 1, I am going to say neighbor 3.3.3 remote AS 65000, neighbor 3.3.3 update source loopback 1, and then address family IPv6 unicast neighbor 3.3.3 activate. This is the only configuration, and here you need to add one more command, neighbor 3.3.3 neighbor 3.3.3.3 and send label, because if it will router 1 will not send any label to this neighbor when router 1 will advertise this network which is connected on router number 6 to 2001 double colon 6/128. When router 6 will advertise it to router number 1, because we will have one BGP session between router 1 and router 6 also. Then router 6 will advertise this to router number 1, and router 1 will advertise it to router number 3 without label. So next hop is not reachable. Next hop will be what? IP address of router number 6 interface, fast Ethernet 0/0, because router 1 is advertising this prefix to their IBGP neighbor. Okay, so let me remove this command. Later on I will run this command. First of all, let me show you the problem. Okay, so this is configuration of router number 1. I am going to paste this configuration in the console of R1. First of all, let me access all router R1. First of all, I am going to configure a customer A IPv6 service. First of all, we are going to provide, we are service provider, and we are going to provide IPv6 connectivity to customer A, and then we will come to customer B. So let me access router number 3, router number 6, and router number 8, because configuration is exactly same for customer B also. So on router number 1, I am going to configure. Before that, if you want to check reachability, ping 3.3.3.3 and source 1.1.1.1, you can see there is reachability, because I have already configured OSPF. This video is like previous video. In previous video, configuration, how I have configured the topology. So OSPF is running and MPLS is running, because of OSPF 1.1.1 and 3.3.3 are reachable with each other. So on router number 1, I am going to say router BGP 65000 and then neighbor 3.3.3.3 activate, sorry, remote AS 65000 IBGP neighbor, the neighbor 3.3.3.3 and update source loopback 1, and no BGP default IPv4 unicasting, and then address family IPv6 unicast, and I am going to activate this neighbor 3.3.3 activate. You can see it's saying first enable IPv6 unicast routing. So that's why first of all I need to run IPv6 unicast routing command, unicast routing, and then router BGP 65000, and then address family IPv6 unicast, and then neighbor 3.3.3.3 activate. This is configuration of router number 1. After that, on router number 3, router BGP 60, and before configuring it, let me enable IPv6 unicast routing. After that, router BGP 65,000, and then no BGP default IPv4 unicast, and then say neighbor 1.1.1.1 remote AS is again 65,000, and neighbor 1.1.1.1 update source loopback 1 and update source loopback 1, and until and unless I will not activate this neighbor for IPv6, neighborship will not come up, right? As you know, for IPv6 you have to activate the neighbor. For IPv4 it's automatically activated. So address family IPv6 unicast and neighbor 1.1.1 activate. Now we are expecting BGP neighborship between 1.1.1 and 3.3.3. So just wait for some time, you will see there will be one BGP session between 1.1.1 and 3.3.3. You can see the log message, and exactly same configuration are there in Notepad. Okay, so I have run this command on router number 1. I have run this command on router number 3. After that, we need to configure BGP between router 1 and router 6. So first of all, we need to configure IPv6 address on fast Ethernet 1/0. You know, service provider will upgrade their provider edge router only, right? On provider edge router, they are going to configure IPv6 address. So here between router 1 and router 6, I am using this IPv6 network 2001:db8:1:6:0/24 like previous video. So this is IP configuration of router number 1. On router 1 fast Ethernet 0/0, I am going to configure this IPv6 address. So let me take you to R1, and here let me paste this command. This is IP configuration only. I have assigned this IPv6 address on fast Ethernet 1/0 of router number 1. After that, we need to assign IPv6 address on router number 6 also. So here is configuration. You can see on fast Ethernet 0/0, I have configured this IPv6 address, and I have created one loopback. On the loopback, this is the IPv6 address. Let me copy this part of configuration and let me paste on router number 6. This is router 6 configuration, and then we will configure BGP neighborship between router 1 and router 6. So now let me configure BGP neighborship between router 1 and router 6. So guys, on router number 6, you can see first of all I am enabling IPv6 unicast routing. Configuration is similar like previous video, so that's why we are not going to discuss each command in detail. Okay, router BGP 100. After that, here we don't have any IPv4 address on router number 6, so we have to define BGP router ID. So BGP router ID 6.6.6.6. Then no BGP default IPv4 unicast, then neighbor, and this is IP address IPv6 address of router number 1 2001:db8:1:6:1 and remote AS 65,000. Then address family IPv6 unicast, and I have activated this neighbor, and then I have advertised the loopback network 2001:6/128. And after that, as you know, on router number 1 we can run AS override for this neighbor, or we can run allow AS in on router number 6. So here I have used allow AS in on router number 6, because when router 1 will receive prefix IPv6 network of router number which is running on router number 8 from router number 3, actually this prefix, when router 8 will advertise this prefix to router number 3, router 3 will advertise it to router number 1. When router 1 will advertise it to router number 6, router 6 will not accept it, because router 6 will get their own ES number 100 in the update message. Okay, so that's why here I have run this command allow AS in. Okay, then router number 1, router BGP 65,000 neighbor, this is the IPv6 address of router number 6 2001:db8:1:6:6 is the IP address of router number 6 and remote AS 100, and then address family IPv6 unicast, and I have activated this neighbor. This is the only configuration to enable BGP session between router 1 and router 6. First of all, let me copy this part of configuration and let me paste this part of configuration in router number 6 console. So let me take you here. I am going to run this command. Okay, so here router ID. Okay, this is the error message, but I have defined the router ID on this router, so we don't have any problem here. After that, let me copy this configuration and let me paste it on router number 1. Now we are expecting one BGP session, one BGP neighborship between router 1 and router 6. Just wait for some time. We will see one BGP neighborship between router 1 and router 6. You can see on router number 1 log message 201 colon db 8 colon 1 colon 6 double colon 6 is up. This neighbor is now up. And now here on router number 6 we have advertised one network also in BGP. So if you will check BGP table, so BGP IPv6, so you can see in BGP table it have installed this network, right? In BGP table it have installed this network, and then it will advertise, router 6 will advertise it to router number 1. So let me show you BGP table of router 1 also. So BGP IPv6 directly. So here you can see it have learned this network. When router 1 will advertise this network to router number 3 to their neighbor 3.3.3, it will advertise with same next hop, this next hop, and this next hop is not reachable from router number 3. So because of that, on router number 3 you can see, so BGP IPv6, here you can see router 6 have received this prefix, but this is not best, this is only valid. This is only valid because of this next hop, because this next hop is not reachable from router number 3. So what we can do, we can tell to router number 1 that please send label with this prefix, please send label with this prefix. See, on router number 1 I can configure this command, router BGP 65000, and then we can say address family IPv6 unicast and neighbor 3.3.3.3 and send label. I already used this command in previous video, so hope it is clear to you. After that, on router number 3 also I'm going to say router BGP 65000 and then address family IPv6 unicast and neighbor 1.1.1.1 send label, send label. And now if you will check BGP table, so IPv6 so BGP IPv6, you can see this prefix is best as well as valid. This prefix is best as well as valid, because now this time next hop is this one 1.1.1.1, right? This is, guys, different type of address. I will discuss this address in one separate video, right? By the way, I have already discussed this type of address, this address in IPv6. It is combination of IPv6 and IPv4. Always there will be 4 time F, and after that IPv4 address, after that IPv4 address, and this next hop is reachable from router number 1. That's why you can see this network is valid as well as best. Now when we will configure one BGP session between router 3 and router 8, router 3 will advertise this network to router number 8 also. So let me configure quickly neighborship between router 3 and router 8. Before that, I have to configure IPv6 addressing between router 3 and router number 8. So here you can see this is IPv6 configuration on router number 3 on fast Ethernet 1/0. I am going to configure this IPv6 address 2001 colon db8 colon 3 colon 8 double colon 3/64. Let me copy this configuration and let me paste on router number 3. And then let me configure IP address on router number 8 also. So this is IP configuration of router number 8. You can see I am creating one loopback and one IPv6 address on fast Ethernet 0/0. Let me copy this configuration and let me paste on router number 8. Router number 8. Okay. And now we need to configure BGP session between router 3 and router 8. So here again command, we have command is exactly same like we configure BGP between router 1 and router 6. Exactly same way we are going to configure BGP session between router 3 and router 8. You can see router number 8, router IPv6 unicast routing, then router BGP 100 and BGP router ID 8.8.8, no BGP default IPv4 unicast, and then neighbor, this is the IP address of router number 3, and then remote AS 65000, address family IPv6 unicast, and neighbor activate, and then I have advertised this network, right? And after that neighbor allow AS in. Okay, let me copy this part of configuration and let me paste it on router number 8. So we have enabled the BGP on router number 8. Now we are going to enable BGP on router number 3. After running these command on router number 3, we will expect one BGP neighborship between router 3 and router 8 also. Let me run this command here. And now wait for some time, we will have BGP session between router between router 3 and router number 8. And now if you will check BGP table, so BGP IPv6, you can see router 3 have learned this network from router number 1. This is IPv4 mapped address, and it have learned router 3 have learned this network from router number 1 from 1.1.1.1. Actually this is IPv6 address, but this address is called IPv4 mapped address. IPv4 mapped address, we discussed this address in IPv6 series. And after that it have also learned this network from their neighbor 8.8.8. and let me check 8.8.8 that router 3 have advertised this network to 8.8.8 or not, because we have already configured allow AS in on router number 8. So let me take you to R8 and let me check. So BGP VPN v4 sorry so BGP IPv6, yes, router 8 have learned this prefix 201:6/128, and this is the next hop IP address of router number 3. Okay, and let me take you to router number 6. Let me check router 6 have learned or not. Yes, router 6 have also learned this network from router number 1, right? And let me check the connectivity. Ping 2001:8 and source is 2001:6, and you can see there is reachability as well. So this is how service provider is providing IPv6 connectivity to their customer. And in the same way we can configure for customer B also, like there is no any difference. Here we have command on router number. First of all, we will form BGP neighborship between router 4 and router 2. So this is command of router number 2. On router number 2, I am saying neighbor 4.4.4 remote AS 65000 neighbor 4.4.4 update source loopback 1, and then address family IPv6 unicast and neighbor 4.4.4 activate. I have not configured IPv6 address in service provider network, right? I have only configured IPv6 address on P router. Let me copy this part of configuration and let me paste on router number 2. Let me take access of router 2, 4, 7 and 9. This is configuration of router 2. Let me copy and we can paste this configuration on router number 2. Do ping, because 4.4.4 should able to ping 2.2.2. Yes, it is able to ping. Let me paste the command. Here I have pasted the command. After that, in the same way, we need to enable BGP on router number 4. So this is the command on router number 4. Let me paste this command on router 4. And after that we will have one BGP session between router 2 and router 4. Configuration is exactly same like we configure BGP between router 1 and router 3. In the same way we configure BGP session between router 2 and router 4, and you can see we have BGP neighborship. After that we can configure IPv6 address on router number 2 fast ethernet 1/0, on router number 7 fast ethernet 0/0, and on loopback interface, and then IP address on fast ethernet 1/0 of router 4 and fast ethernet 0/0 of router number 9 and loopback interface on router number 9, and then we can configure BGP between PE to CE. So here is the configuration, IP configuration of router number 2 fast ethernet 1/0. On router number 2 fast ethernet 1/0 we can configure this IPv6 address. After that we will have IPv6 address configuration on router number 7. So let me copy this configuration and let me paste this configuration on router number 7. Okay, and then we need BGP neighborship between router 7 and router 2. So here this is the configuration of router 7. You can see exactly like router number 6. Here I have defined BGP router ID 7.7.7, and then neighbor, this is IP address of router number 2 remote AS 65000, and then in IPv6 unicast I have activate this neighbor, and then I have advertised this network and allow AS in with this neighbor. I have allow one AS here. Let me copy it and let me paste it on router number 7. Router number 7. After that we need to configure BGP on router number 2. So let me paste this command on router number 2. Now I am expecting that you are very familiar with these kind of configuration. That's why we are not discussing, command. And here you can see we have BGP neighborship. And now if you will check, so BGP with BGP IPv6 here. So BGP IPv6 here, you can see in BGP table router 2 have learned this network 2001:7/128, right? In the same way we can configure IPv6 address on router number 4. Let me copy this command and let me paste it on router number 4. Then router number 9, IPv6 configuration, router number 9. I have already I have already come with all command so that we can reduce the time, right? Otherwise, because configuration is not hard, configuration is very easy. On router number 9 we are going to paste this command to enable BGP, and then to enable BGP on router number 4 we are going to run this command, router number 4. And now if you can check, so BGP IPv6 here, this network is not best only valid because of next hop IP address. So we need to run two more command, on one on router number 2 and one on router number 4. Let me run that command, router BGP 65,000, and then we can say address family IPv6 unicast, and then neighbor 4.4.4.4 and send label. That's it. And then router number 4 config t router BGP 65,000, and then neighbor 2.2. Sorry, address family IPv6 unicast, and then neighbor 2.2.2.2 and send label. That's it. Now if you will check again BGP table, so BGP IPv6, you can see both prefixes valid as well as best, and we can check the connectivity from router number 7. I am going to ping 2001:9, source is 2001:87, and now you can see there is reachability. So this is the configuration of 6PE. Okay, so hope guys it is clear to you. Now in MPLS series, from next video we are going to start traffic engineering. That is very, very important. Okay, so till now we understand IP L3 VPN, and then we discuss how to provide IPv6 connectivity over MPLS, and then we are going to learn traffic engineering. So from next video I am going to provide you video on traffic engineering. First of all we will understand what is traffic engineering, and then we will see the all topics of traffic engineering. Okay, that's all for today guys. Bye bye, thanks for watching.